Okay, welcome back. In this last section, we're going to look at equations and look at how to convert them back and forth between the two systems. So this one, example 5, we're starting out in rectangular and we have to go to polar. So again, you're changing your x's and y's into r's and thetas. So those formulas that we saw earlier, this is kind of what we're going to be using. So we need to look for some of these to kind of pop out in our equations. So right here we've got one of them. X squared plus y squared. Well, according to our little conversion thing, x squared plus y squared, that equals r squared. So we can replace that whole left side with an r squared. So the right side, the x, well, we have something for that as well. We have x equals r cosine of theta. So the x gets replaced with r cosine of theta. And typically for these, when you go into polar form, if you can solve pretty easily and get the r by itself, go ahead and do it. So what we're going to do with this is we're going to divide both sides by an r. And so we get r equals cosine of theta. So now we're allowed to do that because normally you don't want to divide by a variable, but that's because you don't know if the r is actually equal to 0 or not. Well, with polar coordinates, the r is probably not going to be a 0, so you can get away with it. So r equals cosine of theta. Okay, let's go ahead and try part B. So we have x squared equals 4y. So again, the x is just r cosine of theta. But it's being squared, so I need to square it. And then on the right side, I can leave the 4 where it is, and then the y, I'm going to turn that into r sine of theta. And then just kind of work with it and try to get the r by itself. So I got to square out the left side. You can divide both sides by r. So now there's only one r in the entire equation. So if I can get this by itself, then I'm pretty much done. So let's divide everything by cosine squared. So r is equal to 4, and then we don't usually leave trig functions in the denominator, so we're actually going to kind of switch this out. So there's 2 cosines down there, cosine times cosine. So I can do sine over one of the cosines to give me tangent. And then the extra cosine in the denominator would turn into secant. So r would equal 4 tangent theta secant theta. Now let's go ahead and reverse our process. So now we are in polar, and let's go into rectangular. So we have r equals r sine of theta. So the r I could switch out, because the r I could change it into just the square root of x squared plus y squared. But the sine of theta, that's going to be a little tricky. One, because they give you a fraction, we don't really like that. Plus, it kind of starts having y's and r's in there. It just gets all messed up. So let's just not do that. So instead, let's multiply both sides by r. Because then your left side is r squared, and then your right side is r sine of theta. So now that right side, r sine of theta, that's just y. And then r squared, is x squared plus y squared. So multiplying both sides by r, it avoided having to make a fraction, and it avoided needing a square root in there. And then for these, what people usually do is they usually just set everything over to one side and set it equal to 0. Okay, so let's do part C. And we're gonna, first, we're gonna eliminate the fraction, so we're gonna cross multiply it. So 3r minus r cosine of theta is equal to 3. So this r next to the 3, we'll make that x root x squared plus y squared. The r cosine of theta, that's just x. And 3 is just 3. And we're gonna try to get rid of the square root. So we're gonna swing over the x. And then we can square both sides. So the right side, I just gotta FOIL it. X squared plus 6x plus 9. And then over here on the left, the square root and the square cancel out, but then don't forget you still have the 3 to also square. So 9 times the quantity of x squared plus y squared. So just distribute. And then set equal to 0. So 8x squared plus 9 y squared minus 6x minus 9 is equal to 0. Okay, and that will do it for section 9.1. So go ahead and check out the homework. The notes are also going to be online, so you can check out the examples that we didn't do. So let me know if you have any questions, and that'll do it.